All right, so this is the answer video for worksheet 5 for second period. Again, there'll be another video that you'll find that's fourth period going over different problems. So watch them both if you need to. All right, number 16. Again, this is worksheet 5, which is the review worksheet. I guess before I get started, what's due on Friday is the packet. It's easy. The packet's due. The test is set up very similar to the review. I would say the main exception would be the test does not have that many unit circle problems on it. It has, I don't know, 8 or 10, I think, but it definitely doesn't have
60.
However many that is. 4 times 40? Is that 40 problems? Yeah.
Just right there.
So it has some, but not that many. Otherwise, the test is set up really similar. All right, back to number 16. If y equals a sine x minus h plus k is the equation for that graph, then what could be the values of a, h, and k? Okay, well, sine graph, before I even look at that graph, I'm just, in my brain, I'm thinking that's what a sine graph looks like. Like I need that parent function in my head when I see sine. So, let's see. Let's find the midline first. If I'm thinking about A, B, C, D, D is the midline. It goes up to 3 and down to -5. That means -1 is right in the middle. And that would be K. And, well, that doesn't really help anything because they're all K equals -1. So I guess that's good. C would be the left-right shift, the starting point. So let's see. If we're going x minus pi over 4, that would be right pi over 4. So that would be a starting point right here. What do we think about that? Yeah, that could not be a sine. That would be a negative cosine wave. So that's out. I can't do that. H equals 3 pi over 4. So if it's x minus 3 pi over 4, what does that mean in terms of which way we're going? Left or right?
No, right.
Right, because that minus sign, so be careful. So that's right 3 pi over 4. In fact, both of them are right 3 pi over 4.
So that's right.
So let's see if that looks correct. Right 3 pi over 4 would put me right there. That looks good. So I'm good with both of those.
So because it's on it works.
Well, because that's where a sine starts. Be careful, a cosine wouldn't be on it.
It's just the way the graph.
So if this is my starting point, what would A be? 4 or -4, or either one? It would have to be 4 because this isn't flipped. So that last one would be a flip. So 2 only is my answer. Now, it's okay that A is -4. That would happen if we started here. Right? That would have an A of -4 if this was my starting point. That would be x plus pi over 4. So that would be another way to write that equation. So you can have different starting points, and then your combination of starting point and A, whether it's flipped or not. So good question. We hadn't done many like that. Tori?
So why is when you have your normal tangent like graph, it goes to the middle. Why is cotangent like to the left and not to the middle?
Okay, tangent versus cotangent. That's a good question. So the question was, tangent looks like this, and has asymptotes at pi over 2. Cotangent has asymptotes at the pi's and is decreasing, like that. So the question is, why are the asymptotes different, I guess? Is that... like one of them's at the pi over 2's and one of them's at the pi's?
Yeah.
Okay. Because tangent is sine over cosine. So wherever cosine is 0, that leads to asymptotes, because that means the bottom is 0. Draw another one here. Well, cosine is 0 when x is pi over 2, thinking about the unit circle here, 3 pi over 2, etc. So that puts an asymptote at pi over 2 and 3 pi over 2 and all the pi over 2's. Cotangent is cosine over sine. So that means cotangent has an asymptote when sine of x equals 0. That leads to an asymptote. Well, let's see. Unit circle, sine of x is 0 when x is 0, pi, 2 pi, and so on. So that's the denominator determines asymptotes, and because tangent and cotangent have different denominators, because they are flips, reciprocals of one another, that means they have a different set of asymptotes. Does that answer your question? That's a good question, and that covered a lot of stuff right there. We could ask a lot of questions about where are the asymptotes of tangent, where are the asymptotes of cotangent. Plus, it's a good review of what the graphs look like. While we're there, what's the period of each of those graphs? Pi. Both of them have a period of pi. While we're talking about similarities, what's the range of each of those? Negative infinity to infinity. So yeah, they're different, but they do have some things in common. There's some characteristics of those graphs that are shared. So that was a good question. That was a good sine or good tangent cotangent review there. How about more questions from the review? 21. Which does not have the same graph as y equals sine of x. Alright, so let's graph sine of x and then we'll go from there. Okay, I'm trying to think what's the best way to do this. I guess we'll just graph each of these individually and see if they match our sine of x graph. Okay, so cosine, but minus pi over 2 means we're going right pi over 2. So I'm going to start at pi over 2. And where does cosine start? What's the parent function of cosine look like? Yeah, it starts at a max. It does that. So if I'm at pi over 2 and I'm at a max, and that graph looks like that. That's kind of weird to look at. Are those graphs the same? They are. They don't look the same because I didn't graph the same like window of them. But if I continued this backwards or continued this onward, then yeah, they are the same. So A works. All right, the graph of B plus pi. So that means we're going to go left pi. So left pi, and start from there. Is that the same graph as the sine x? Again, it's tricky to look at because what we graphed looks the same, but it's not in the same spot, right? We moved it to the left by pi, and so it's not the same graph. I want to keep going. It's like the flip of the graph. So B doesn't work. Let's do one more of these because it must work, but I want to see that it does work. So x minus pi is right pi, and the negative sign is flipped. So I'm going to go right pi, start here, but it's flipped, so I'm going to draw it like this. Again, is that the same graph as our original? It's like, well, it doesn't look like it, but if we drew all of it the right way, it is. So C does work.
Could you also draw D?
Sure. Like, pretty sure D is going to work because B didn't work, but let's draw D to make sure. So we got a flip, and we got a left pi over 2. So left pi over 2, but it's flipped. So normally it starts at a max. Cosine starts at a max, normally. But because it's flipped, it's going to start at a min. And 2 pi away, it'll be at another min. And halfway in between there, it'll be at a max. So is that the same graph? Yeah, I mean, if we kept going, it does match. So it's a good example of there's 4 different ways to write that one graph. There's more than that. That's 4 examples of a way to write that. Good question.
Ones where 28 and 29 where we have to write or state the equation.
Okay. Let's do 28. State an equation of the sine curve. So I'm going to go ahead and write the sine curve, and then I'll just fill in where I need to. Period of 5 pi. So what do I do with that? What do I do with 5 pi? What's the period equal to? 2 pi over b. So 5 pi equals 2 pi over b. So if I move things around, multiply both sides by b, divide by 5 pi, I get 2/5. That's the hardest one, the rest are easy. Amplitude of 7, so where does that go? For A. Our favorite one. A phase shift of pi over 3, a right phase shift of pi over 3. So how do I accomplish right pi over 3? Yeah, x minus pi over 3. And then a vertical translation of up 9. So there's a nice color-coded answer. Do we need to do 17, 18, 19, or 20? The ones where you graph, or there's more graphs at the end here, I think. 30 through 32?
Yes.
So you got a preference on any of those?
Either a cosine one or a tangent one.
Okay, so let's do 17. I'm thinking ABCD still. To me, that's the easiest way to handle these. ABCD, DCBA. So what's A for this, for number 17? What's the amplitude? Yeah, I should be careful. A is -1. Amplitude officially is 1. But that negative means it's flipped, so I need to be careful. So amplitude of 1, but it's flipped. What's B equal to? This one's maybe tricky because B is right there in front. So 1. So what does that mean the period is? 2 pi. It's not changed. All right, what's the minus pi over 2 mean? All right, pi over 2. And the plus 1 at the end, up 1. Again, A, B, C, D, use them in reverse, D, C, B, A. So up 1, that's my new midline. Right pi over 2 is my new starting point. The period is 2 pi, so I need to go 2 pi away from pi over 2. So where's that going to be? Slightly off the graph, but not much off the graph. It's just the next hash mark over would give me a width of 2 pi. So I need to fit my cosine graph in between pi over 2, and I guess that would be 5 pi over 2. Again, I think it's helpful to do a quick sketch of the parent function. That might be a good idea when you first get your test on Friday, is to sketch the 3 parent function graphs, sine, cosine, and tangent. That way, you'll be able to answer a lot of questions looking at those, and when it comes to graphing, you'll have something to look at. All right, it's flipped though, so normally I start at a max, but today, or for this problem, I need to start at a minimum because it's flipped. 2 pi away, it starts over. Right, every beginning, every ending is a new beginning, or something like that. How about halfway in between the 2 mins? What's going to be going on halfway between the 2 minimums? A maximum. Then halfway between there would be zeros. So there's sort of the parent function shift of the thing. Now the instructions say graph it from -2 pi to 2 pi, so I need to keep that pattern and move it backwards. So I guess 2 ways to do this. One way would be to go 2 pi away again and kind of work the same process. Every beginning is another ending or whatever, so that's a minimum. Halfway in between of those would be a maximum. The other thing that people do is just follow the pattern. Minimum 0, maximum 0, minimum 0, maximum 0, minimum. Oh, and I guess to get to negative 2 pi, I need to go up one more time. So we've graphed some sine, we've graphed some cosine, we've graphed some tangent.
We don't number
33. Oh, yes. Writing an equation from, or no, it gives us the equation. We've just got to figure out what is going on here for 33. A model for the average high temperature in Las Vegas is given by that thing. T in months. T equals 1 corresponds to the month of January. What is the period of this model? So period is 2 pi over b. So 2 pi over, what's b equal to? Pi over 6. So keep it, change it, flip it. We end up with 12. Indicate units of measure. Well, let's see. T is in months. Period is like the x. If we graphed it, period is how far we're going in the x direction, or in this case, the t direction. So that's 12 months. Explain the meaning of the period in the context of this problem. It's a year. It takes one year is one cycle, I guess. One cycle or one period is 1 year. That makes sense. Like after a year, it starts over again, right? Because you're back to January and you have back to the same average high temperature for January. What is the maximum average high temperature in Las Vegas? So we did one problem like this a while back. Let's think through what these pieces are here. A little bit out of order. That's D, that's A, there's C. D is the midline. So what does D represent in terms of the graph? Maybe, yeah, the average of the average high temperatures. So that would be up there at 80.6. Would be where the midline is. A represents the amplitude, how far above and below we'll go. So if we want the maximum, I think that would be the midline plus the amplitude. All right, so we'll start at 80.6, and somewhere along the way we'll be 23.5 above that. So whatever that is, 104.1, I think, is the maximum that the graph gets to. Show the work that leads to your answer. Well, the work is I added the average midline to the amplitude to get me to the maximum. What else? Do we need to do some unit circle problems? Just to review, short side, long side. Let's just do a quick review down here at the bottom. All the over 6s are the shallow. All the over 4s are the mediums in the middle. And all the over 3s are the steep. All the long sides are root 3 over 2. All the middle sides are root 2 over 2. And all the short sides are 1/2. That's how we remember. I don't memorize the unit circle. I figure that out, and then I can go answer anything I want. So let's do a tangent, because that's weird, right? Let's do the tangent of 5 pi over 3. Where did that one go? Number 50. So where's 5 pi over 3? What quadrant?
That's going to be
Why 4?
fourth. It's a steep.
Because it's almost 2 pi. So quadrant 4, and then over 3 means it's steep. So steep angle, 4th quadrant. I know tangent is y over x. The y side looks like a long side, negative 3 over 2. The x side is a short side, 1/2. And then you can keep it, change it, flip it, or maybe you've done enough of these where you know those 2's will cancel and you're just left with negative root 3. Let's see. How about one of the quadrant markers? Sometimes that throws people off. Like cotangent of pi over 2, number 73. Sine is the y coordinate, cosine is the x coordinate. Cotangent is the flip of tangent, so it's x over y. What quadrant is pi over 2 in?
It's the top left.
Good. Trick question. It's the top. So that coordinate would be 0, 1. Make sure you get that right, or else you're going to mix up who's x and who's y. So the x coordinate is 0, the y coordinate is 1. So the cotangent of pi over 2 is 0. Again, you don't really memorize many values. You know where the angles are.
So if zero's on top, it's going to be 0. If zero's on bottom, it's undefined.
Correct.
Because that's what I got mixed on the test. The last
The
test.
okay and no thing, if zero's on top,
Yeah.
you're okay. If it's zero's on the bottom, that's not okay. D and E or undefined, or however you want to phrase it.
Can you show the long go forward,
Which one?
like a graph you drew? I didn't.
That's, again, there's different ways to do the unit circle, but to me, if I can remember that much, I can figure it all out from there. And so if you're looking to like sort of build your own cheat sheet the rest of the year, when you get a test, I frequently see stuff like this, like written on the test from here on out. Eventually, maybe you don't even need it, but a lot of times people write that much to kind of get their brain going in the right direction. I think for this test, I'd write that. I'd probably also do, we said this earlier, probably also quickly do the sine, cosine, and tangent graphs. At least their parent functions. And if you remember that much, then you can answer questions about period and asymptotes and maximums and minimums you can start shifting things around with the A, B, C, D. But those are the parent functions. So maybe you don't need to draw those out right away, but maybe it's a good idea to, again, to kind of get your brain in the mode of, sine, cosine, tangent graphs. Charlotte?
Can you show like secant and cosecant?
Sure. So who does secant partner with? Secant goes with cosine. So you know what? I think it'd be easiest to just do it off of the. Let's do it a different way. Yeah, well, secant is the flip of cosine. So wherever cosine is 0, there are asymptotes, and then we just do u's off the maximums and the minimums. So at the risk of muddying up that graph, but there's no way to graph secant other than to graph cosine first and then graph the u's. So it makes sense to put them on the same graph. Cosecant is 1 over sine. So wherever sine is 0, cosecant has asymptotes, and then do the u's off the peaks and valleys. And again, there really is not another way to graph secant or cosecant other than to graph sine and cosine and do the u's. And I don't know, that's a lot to, all that stuff's maybe a lot to do before you even start answering test questions. But if you do all of that, chances are it's going to, in the long run, help you and speed you up as you answer the test questions. Because if there's questions about period or amplitude or asymptotes, you kind of have your sort of building your cheat sheet on the test. Again, all the answers are posted. I will post this video, which you don't need, but I'll post the 4th period video as well if you need more help. Tutoring is a Wednesday and Thursday B block. So today and tomorrow during B block if you want to come in and work some more. So the test is not tomorrow, but I barely see you tomorrow other than for you to check in, say hello, and then go to your counselor. So kind of a weird week, but we built it so that we've been done for a while. It's just, are you using your time wisely to finish the worksheet, study what you need to study, whatever. All right, I feel good that we've hit a little bit of everything, not a lot of everything, but a little bit of everything. Um, 24. Period of a tangent problem. How do we find the period of a tangent problem? Pi over b. All the other ones, it felt like were 2 pi over b. Right? Sine and cosine are 2 pi. Tangent is pi. So pi over, this one would be fun. Pi over 3 pi over 5. I think I would keep it, change it, flip it on that one. To hopefully prevent myself from messing up the fractions. Again, in some ways there's a lot in this lesson. In other ways, it's all the same what we wrote the very first day. Knowing how to handle the A, B, C, and D.